Hello, Z. How are you? Good. How was your week? Did you do anything interesting? Okay, that's okay. Well, welcome to the meeting. We're waiting for a couple people. I think Ankit confirmed that he can be here today, and so we'll see who shows up. Okay. Hello, Stefan.
Hey everyone.
Hi.
How are you doing?
All right.
Good.
Ankit said he'd be here today. I don't know. Might take him a couple minutes to log on, but so how are you guys doing in terms of your terms at your studies and your research?
Oh, so I've been doing quite a lot last time. I'm actually working on Go enrichment pathways in my studies now. So the goal is to write a program which I use Kotlin for, not Java, because I've learned it this summer.
Yeah.
To write a program that would kind of take some, OBO files, construct a DAG tree with Go terms in it, and then we just proceed to make Fisher's exact and Kolmogorov-Smirnov tests on the sets of Gs.
Oh, it's pretty good.
Yeah, so it's quite fun.
Yeah. Here's Ankit. Well, Ankit.
Hey, Ankit.
How are you doing this week?
So I just came back to my campus on 16th, so start of new semester. So
okay.
I was going through the papers and manuscripts. So I was happy that you have put on my part, so I don't have to write from start.
Yeah. So I did some work on the manuscript. I did get some of Ankit's stuff and put it in from the documentation, and I just look it over and see if it's right. I mean, some of it's you always have to double check and everything. Yeah. And then there's some other parts. We're actually getting pretty close, I think, to finishing up. I was noticing that I'll go to the paper in a minute, but we can talk about that a little bit too. So first order of business is the GSoC proposal for 2020, and we're getting those out, and we're starting to get actually mail-in from INCF. I know that Stefan knows who she is. She put these up on the NeuroStars platform. Let me show you.
Cool.
I'm going to share my screen here. Okay. And so this is the NeuroStars platform, INCF NeuroStars. I think they used to be just NeuroStars, and INCF I think took it over. This is based on discourse, and so the projects live up here. So there's the Project 16, which is GSoC 2020. I renamed the proposal Contextual Neurodevelopmental Dynamics. So this is just like a description of the project. So We seek to combine the work of two AI paradigms, this developmental Bratenberg vehicles, which we know here, and contextual geometric structures, which is the one from 2018. And then I give a little bit of description about what it is that you might be able to do with it. Talk a little bit about the languages involved. So we have some approaches that exist in Python and Kotlin, and people can work off of those. And then I talk about joining the group, and that's the proposal. And then in NeuroStars, you actually can respond to this proposal. So there are no responses yet, but usually people reply in there, and we get a conversation going. Let's see. Okay. Then we can go to the next. This is actually where it lives on GitHub. So this is the proposal coming up. There we go. So it's at this link, and this is just the same thing. It's just the version that I worked from and gave to Malin. Yeah, I don't know if we might develop this further as the proposal period continues. So I mean, we might add to it in terms of like descriptions or change it up a little bit. It's always good to have these records. I have them for a number of seasons of summer code in here where they live, and then they've been modified a bit since they were first proposed. So Ankit, did you think any more about like if you wanted to apply for this summer? Or?
Yeah, I'm actually still thinking about it because like my Harvard, like my internship at Harvard is almost confirmed. So I got some funding from somewhere. Okay. So I must be going there. So I'll talk to the professor if how much time I need to devote to that thing. So I would think about like if there is a chance, I'll certainly join because funding is always a concern. So this is like I have worked for it, so we may like continue on this thing.
Well, I don't know how, like, because a lot of times people try to do that and it isn't necessarily successful to do like a double shift. So I mean, I don't know if that's going to be great, but I mean, no, I definitely, if you can go to Harvard and get money for it, but no, you definitely apply and then make sure that you have two options in the fire. So
yeah, exactly.
But yeah, I mean, so I don't know. So you think you're pretty confident in the Harvard?
Yeah, like things have started going in the right direction. So like my professor has sent, like he's about to send me the documents, like the DS documents from Harvard, and then I'll apply for visa. Things like I'm joining on 4th of May this year. So 4th of May to like about 2.5 months or 3 months, something like that. So I'll talk to him, and actually a lot of people from my university only, like a lot of people from my university get into Google Summer of Code, and a lot of people have done things like together simultaneously. Yeah. So last year also, if I was selected in this in our BV project, I was thinking of doing it together. So this year also, if I can like. If I think the project is doable for me, then I should write a proposal, hopefully.
Yeah, I think if you can make it, when I was an undergraduate, I did that when I had courses that were sort of, that could be put together as something where you could it would feed off of itself. You'd have 3 courses and they'd kind of complement one another, so you weren't trying to do, switch back. It was like 2 things that were incompatible at the same time. So, but in this case, if you could find a bridge between them, that would be good. So yeah, I don't know. You have to find out more about the fellowship at Harvard and what their expectations are. Because exactly. I mean, it may be that they want you to do certain things and train for 40 hours a week. So I mean, it's It's always difficult.
Like 40 there and 40 here would be too much.
Yeah, way too much. But like I mean, but I don't know if maybe he wants you to have like a project ready to go, or I don't know what the expectations are. So figure out what those are first, but definitely apply anyways, just to
Yeah.
yeah. So
Yeah.
oh yeah.
Yeah. So I was thinking about finishing off the project, like doing things in advance, and thereafter, like I know only the project, I can start doing it now on like this semester only before May, and then like doing things in like parts after I go back to Harvard.
Yeah.
So if that's an option, then I should consider this very seriously.
Yeah. So let me actually. Oh, hi Jesse. I saw you come in. I didn't get a chance to say hi. So welcome, Jesse. Glad you could make it.
Hello, Jesse.
Yeah.
So actually, let me go back to the GSoC project and let me see if I can find the other projects that we have for DevaWorm. Let's see, here it is. So you can see there are like 20 ideas from different groups. You're there. So we have 15 and 14, but I don't know where 14 is. Okay, the 14 is the pre-trained models for developmental neuroscience. And this one is based on this, and Jesse knows about this, the stuff we were doing in DevaWorm ML last fall. And it's, a takeoff on that. We wrote a blog post on these deep pre-trained models, which are models that they use in deep learning to sort of pre-train the model. They get data and they figure out what the sort of the features are in those data. And then they build a model that's sort of like, they're predefined weights or predefined elements that you can put into a deep learning model that reduce the amount of training data you need for your model to run. Because deep learning models do require a lot of data. And if we had a deep learning or a pre-trained model, we could reduce that number of amount of training data by quite a bit. And so this is a proposal to try to develop one for developmental biology or neurobiology. So to take microscopy images and analyze them so that you have, we can get some features out of them and then put them into a deep learning model so you can take subsequent images, put them into that model and get better results. They've done this. They've been very successful at applying this to linguistics data. So in the area of NLP, they've applied these kind of models to different linguistic data sets where they have a lot of words and sentences that they're trying to analyze. They've also done it for other deep learning models in like for generic features like rectangles and things like that, where you have for like your canonical data sets like your iris data set or your data set of cars or a data set of houses, things that you can kind of easily identify, but you might want to apply deep learning to a set of images to see if you can do this at a very high volume. So people have implemented these kind of models, but this is a call for people to do one for developmental biology, neurobiology. And so we'll see how this goes. We'll get people applying to this. We already have one inquiry. So I found that the machine, anything with machine learning, and it gets a lot of attention. And then there's a third project, and that's also for DevaWorm. And that is this one that I was at earlier, which is the Open Devo Cell Integration. And so this one is a bit less ambitious in terms of like developing something new. It's just one of the person I had working in DevaWorm last year, Vinay Varma, he developed he developed software and an interface for doing deep learning and advanced machine learning on these microscopy images. So he developed a plugin for ImageGA, which is a platform for analyzing microscopy data. He has a web interface that does the same, and he also incorporated some deep learning techniques as well. And then this project is to sort of improve upon that range of that set of tools, and add some new functionality, add some improvements to the web interface. Because last year we were kind of just putting together pieces as we could develop them. It was sort of like, let me see if I can do this. And then he got a lot working, actually. We went quite a ways. But this is to sort of improve a lot of those components. So, and I already have someone is applying, a couple people applying to this already. So, again, like I said, anything with machine learning or deep learning in it is going to be like a hot commodity, I think, in GSoC. But I think, if you know anyone for the other projects who wants to apply, you might mention it to them. Otherwise, like I said, for Ankit, you can apply to the one through, I can't remember what number it is, 13.
16.
Yeah.
Yeah.
So that's good. And then I think I can't remember when the applications are due. I think March 31st. So
it's late this time, right?
Well, they move it around. They wanted the proposals really early, but then Google has to approve everything, and then there's the application period, which is like a month and a half. So it's a decent amount of time. They let these applications sort of diffuse, so that people can get an alert about them, become aware of them, and then do the whole application process. So we'll see how that goes. So yeah, and then we'll update. And then I imagine this is also a good way to get people involved in the organization and to get ideas out there. So, I don't know who's going to apply to what, but there might be some people coming into the group who might be interested in doing things. We'll see. Let's see. So, any other questions on that, or anything you want to bring up?
Not really.
Okay. Well, and now let's turn to the paper. I have to share my screen here. Actually, let me share the link first. And this again is the paper of the manuscript. And I think we'll see that we're moving along on it. All right. There we go. All right, so the title is the same. Abstract has changed a little bit. I've accepted the changes. I think it was Stefano who suggested some changes there. Introduction. Was that a message? Oh.
Yeah, I think so.
My screen won't share it here. Why is it not? Wait a minute. Great. Let me try again.
Sure.
I mean, we might just do that without the screen share. I can't get this to work right, but. Can you see my screen now?
Yeah.
Okay, good. So this is the introduction, abstract. And then trouble kind of moving on the motivation. Nothing's really changed here so much. I want to get down to the part where we were talking about adding things in. I think I did a word count, and we're pretty far up in the word count. So we're around 8,000 words, maybe. I don't know what the limits are for journals. Usually it's, 10 to 12,000, maybe as low as 8,000 for some journals. But so we have to kind of, anything we add now is going to have to be kind of limited in scope, which is, probably okay. I think we have 1,000 more words to work with. There might be some things that are deleted, but we'll see how that goes. It's going to depend on the journal that we want. Most of them, though, don't really have super hard word limits. I mean, some of them do, but we'll work around that when we get to it. So this is the first thing I wanted to point out. This was Jesse's embodied cognition section. So we were talking about Anthony Tremolo, which was the person who you wanted to focus on. And then we were going to pick a definition, Tremolo's definition, I guess, and then work from there. So Jesse, you said you might be able to get working on this like this week or this weekend. Okay, yes, you can stay about 10 minutes. Any thoughts on the paper before you go, or?
I think he said he had like bad internet connectivity or something.
Okay, yeah. Oh, yeah. Okay, I think the portions of the paper I have won't be that much. Some content there. Anthony's stuff will be late today, yes. Okay, good. Thank you. That sounds good. I look forward to seeing it. And again, like I said, it doesn't have to be like this huge voluminous amount. Just a good review of it, and then that'll be good. Yep. And then, so that's good. And then we have feedback and regulation, which is, again, something that can be, I think summarized pretty, easily. It might even be combined if we, which might be better because it's just kind of, we've already got a lot here, so, but I'll think about that some more. And then methods, of course, we have methods for the 3 instantiations. So we have Rajan Brain. I think I told Stefan last week, I restylized the tables and the equations. So here's a table of code. And then we have the equations that are restylized. So these are, like I said, I might have to translate some of these back into LaTeX. But for Google Docs, you have to do this. You have to create them in Google Docs to make them format right. But again, we'll cross that bridge when we come to it. And then, again, make sure that I have everything factually correct in here. Because it's not, I'm just kind of like editing and I'm having to rewrite some things in here just to make sure that it flows better. But I don't know if we have everything we need. Because sometimes, you rewrite things or you put things in there and they don't fully convey the idea. So I think we're okay, but just double check so that we have it correct. And then there's a part on the code, and then we go into C's contribution. So again, we have the equations set up in here, the descriptions, and then, okay, so this is the new part for Ankit's contribution.
So like in the real paper, are we going to like put on the links, or is it for the doc?
Oh, you mean to like the repositories?
Yeah, so we have the repository link and the presentation link here.
Yeah, well, I mean, So this, I'm going to take this out. I just put this in to remind me where to find it. But I'm going to take that out. The link we'll provide in the paper would be this, like this kind of repository, like the GitHub repository. Now I know I don't know exactly which one you want me to point to. So if you,
so like the both ones.
yeah. So I think for yours I put in this one at your GitHub account.
Yeah.
Okay. So then that's all right. So then that's our points, and people can go there, and then it just talks about the code again. And then here are the equations. So I just extracted the wearing and activation and linear and radial acceleration equations, and then those should be those. I run over those again because I'm not sure I got them exactly right, but I think I did. Yeah. All right. Then the code, then the results. Again, we have intro to the results, and then the software instantiations, and then the broad-gen brain approach. So this one I got figures. Those are just screenshots of the environment, and then this one of the network. And then again with Z's contribution here, screenshots and some other diagrams, and then the BV. So I called it BV collectives for Ankits, and we can talk about the name you want to give it, but I just kind of use that as a working title or working name, and then you can kind of get into the description.
And before that, in the method section, you have you have written methods for swarm intelligence and deep learning using these. So still, I haven't implemented the deep learning thing. So we can just keep it to swarm intelligence as an algorithm for BVs, and keep the deep learning approach for in the future plans or something like that. So.
Right.
Because it's not ready for the time being, and it could be like next project or the better version of the project or something.
All right, yeah, that's a good idea. So I think that's kind of what I've done here, and just kind of like going over what's there now, and then over this to kind of go over. So these are the screenshots. And then they're static, so I don't know if you want to make like the videos that you have, if you can make them like
so GIFs are always there. So, but I'm not sure if we are allowed to put the GIFs in the real paper.
Well, probably not in the paper itself. Maybe as like supplemental materials. So it would just be like you'd have a video that would be like you could take a video, put it up like on YouTube or on I don't know if you can put it on GitHub. But like have it available for readers, and then you just say sometimes. Well, you can actually submit videos with like supplemental materials in the paper. So like you can upload it to like bioRxiv, and then upload it to the journal when it's published, and it's just like a file people can download and look at it. So if you want to make videos for that, and then we can, it's not something that is like. If there are things you don't want to show, it's fine, but just a demo that you think that everyone can access, and so that would be outside the paper. It would just be like a link to the supplemental materials.
Exactly.
So these are the screenshots. Then the table. So this is just all the states of the different vehicles, associated emotions. Yeah, and vehicle kinematics, and then the future plans. And I go through discussion, use cases, which we're fleshing out here. So we have the optimized spatial cognition, which is the TSP for spatial cognition. And then this is our type of cumulative classification, which is the deep learning aspect of it. I didn't put deep learning in here specifically, but I'll put it in. I'm finishing this up. I haven't finished it.
Yeah.
All right.
And then this part here at the end, this is just a couple of considerations for some of the limitations and that, and then that's just that's not going to go too much longer, and then that's going to be it. And then we'll have our references. It's 56 right now, so it's probably pretty decent. You don't need that many references, but it's always good to have like at least 50 for a paper that long. So okay, that's the paper as it stands, and like I said, maybe 1,000 more words. And Jesse, I look forward to reading your contributions on that. And yeah, so then next week we'll go over it again, and hopefully I'll get to it more, and maybe Ankit can go back over his stuff and make sure it's good, and we can maybe get, like, I don't know if you want to make demos for the different screenshots, and then we can just put those as supplemental materials. I mean, like videos for the supplemental materials.
So, I would be like very much free in the upcoming weekends and in next few weeks. Okay. So I would I would really do something with the paper and my parts, and I was thinking about like some of the things that we discussed about future plans and use cases and things like that. So I had some ideas also. So I would write that up and get back to you. Thanks.
Okay. Yeah. Yeah, it's good. Any other comments on that? Okay. Well, good. And again, if anyone like Stefan or Z want to go over once more, make sure that everything is their liking, then we can that they're welcome to do that. And then we can also work on Slack if you have any ideas that you want to like bring to my attention pretty quickly. That's a good way. So let's see. Last thing I wanted to talk about was I know that Ankit mentioned some interest in the fQXI assay, and so did Jesse. Yeah. So we again, I wanted to just go over that again. So the news on this too is that Jesse and I started a Slack channel for this. So I'll add Ankit to it, and we can start discussing it a little bit more in depth. But yeah, there's a Slack channel now, and I wanted to pull up where this lives. So this lives on GitHub. And let me put the link in here for Ankit, or if anyone else wants to go to the link. Jesse wants to go to the link. Here it is. This is like so this fQXI is a group. They're interested in fundamental research, and they have these essay contests every year. And this year it's undecidability, uncomputability, and unpredictability. And I started an outline here of kind of the thing that I was interested in. I thought might make a good topic. And so it goes through this idea of what makes a problem hard to represent. So, I'm kind of describing why that's relevant up here. And then, there are a number of different things that are involved in this idea of hard to represent problems. They're difficult to quantify, they're difficult to symbolize, and sometimes you have unphysical problems which are hard to represent using a sort of traditional computer science approach or mathematical approach. And so kind of we give a couple of examples of, why things are hard to represent. Then we get into some questions related to these issues. And that's kind of an open forum right now. It's just if you read through it and you can think of a good question that results from this, you can put it in here. I've put in 3 now, but there are probably more. And then this is a new paradigm that might exist. And I'm just kind of reaching here. I just put down some notes, but like this is going to be something that'll be developed more in the coming weeks, where we have a new paradigm for looking at these things. It's just a shot in the dark. It's not like we have to really prove ourselves greatly here. But it's just like, we're just trying to be very speculative, but also grounded in some sort of reality. So it's we'll have to put some references in. We'll have to kind of work through the argument a little bit more, and I definitely want to talk about this in more detail in the coming weeks. I'm not really prepared to talk about it today too much, but here's an idea. If you want to go in to this repository and issue a pull request, just kind of like going through and adding maybe some notes. I added notes on this document. So you see this up here, it's a note. If I go to edit the file, I've put these little this little notation in front of the notes.
Yeah, so this is marked down, right?
Yeah, this is all marked down. So these little tabs here are in front of the notes. And then if you go into the document, it shows up as this grayed out area, so we can distinguish it from the text. If you want to make like edits to the text, you can put them in. And then, of course, because it's GitHub, we have the versions. So we have version control. So, it should all be... I've done collaborative documents in GitHub before. It's pretty easy to do.
Yeah.
So it's just in Markdown. You put in your text. In this case, there's very little like formatting. It's like you have the headings, which are these little pound signs, and then there's some hybrid HTML that you can add into documents to align things in that, but it's basically text. So you can issue a pull request to that to add things in, to add notes like that, or you can put them in the Slack channel. And I've been kind of working on this little by little, kind of fleshing out ideas into paragraphs. And it's not always like sometimes you don't always get where you want to go exactly with that. So it's always a challenge, but that's the way I like to write and put ideas out and then flush them out later. But we will need to find some citations as well for this. So if you read through and you can think of a good citation, put it at the bottom actually, I can just add that in now. Add in like a heading for citations. And then it would be like, be in the 1, 2, 3 format like this. And then you just put the number in the text where you think the citation should go. So if you want to go here, you might go 3 like that. And then you match it up with the, you put the reference next to the number that you put in the text. So everything tracks. Sometimes, there will be like intermediate things where if there's like a 2 here and a 3 here, you might create a 2.5 here just as a placeholder and then put it in the references. And then at some point we'll renumber them. I don't have a template for automatically renumbering them, but usually I just do it that way. You have to commit. Oh, okay. So that's pretty easy. And then like topically, I guess it's just a matter of 2 things. One is to kind of go through and think about the content, and if it's like if you can think of something new that I didn't consider in this paragraph, you can insert it as a sentence, or you can add in like maybe a point underneath something, and put a reference, and that would be good. So that's something we can work on. It's due in March. I think March 15th is the date that it's due. So we have a bit of time on that, several weeks.
So I'm always interested in such kind of write-ups. So and I have time also this semester, so I'm very much willing to put stuff on that all. So yeah.
Okay. Yeah, I mean that's good. So yeah, I'm looking forward to that. So that's pretty much all I have for today. I think the 3 points, and then of course the GSoC project will, as it kicks off, we'll have people interested in different things, and they might come in and join us in the meetings. I'd like to. I don't know. I want to give you guys the opportunity, if you guys are interested in presenting anything this semester. I'd be welcome to host you if you want to do like a 20-minute presentation on something, or if there's a topic you want to talk about. I know Z was working on some interesting stuff last semester. I don't know if he's got like any new projects this semester he wants to talk about, or get some feedback on. But that would be welcome as well. So I don't know what the. Yeah, I mean, just let me know in advance in Slack or something if you want to do it. So let's see. Okay. Z says, I'm continuing the projects I started last semester. So how about that? Did you do any more? Or are you thinking more about you had that project where you had the retina, you were trying to simulate the retina using a genetic algorithm? It's probably been not that much more progress made on it, but oh, you're collecting data. So it's like in a model organism that you're collecting data, conducting different experiments. That's good. Yeah, that's good to have data that fit, that you can validate your model with. So, yeah, you have a rat model, I think, or a mouse model. Yeah. So, I used a perceptron to evaluate the fitness, and also trying to find another way to directly evaluate the processed visual input. Okay. Just thinking about the other way to evaluate it, other than a perceptron. Like, you mean like some sort of data analysis technique, like a multi-dimensional approach, or like machine learning or something, or is it just something like a neural network? What were you thinking? Signal processing. Okay, yeah, that would be definitely work. Okay, yeah, that would make sense. Well, yeah, if you have continuous data. So what your data is? What is it, like electrophysiological data, or is it? Signal processing techniques are interesting. Something, yeah, we haven't really talked about too much in the group here. It might be interesting to talk about. I mean, I don't. I mean, I know a little bit about it, but it's like it can get pretty intense, like in terms of what you're dealing with, in terms of the method. I mean, you can implement them in different programs, like scientific computing languages and MATLAB and things like that. But you have to kind of know, you have to kind of make sure you know what you're doing before you do it. There are a lot of assumptions in them. So I mean, but I like that idea. Being able to have like a couple of different ways to do that computationally. So, well, keep us posted on the progress on that. That sounds pretty exciting. So Stefan has been working on bioinformatics and some techniques. Are you like? So are you in? You have a couple of new projects, fairly like from last term that you're still working on, Stefan?
Yeah, you mean bioinformatics project or just generally?
Yeah.
Because I kind of finished my studies in bioinformatics now, and I just do, for instance, I do this Go enrichment as a, so to say, homework. What we prepare, we then prepare for so-called block phase. So right, during semester we do some exercises. Let it be Go enrichment or maybe Ritz mapping. We also did differential expression, of course, which I also really liked. Did on R, and the point is that we learn like some basic analysis workflows in the informatics, which we later, like after the semester ends, we still have block phase in the semester holiday this year, and we apply them to some real project. And my real project would be comparing GTX data for males versus females. So for that, I would just I wouldn't really do some big work on mapping reads because they basically close reads, not for others, for the public, not to be able to identify concrete exact persons from the reads. It's kind of data security. So, and I'm also, honestly, I'm not really that interested in like mapping reads or working with BAM files directly. I would be like, just take gene read counts and do differential expression analysis and Go enrichment basically. And that's what I'll be doing in holidays.
Oh, wow. Good.
Right. And so then I'm planning to continue on the phages project. It's pretty extensive, but it's mostly comparing config counts. That's the main point. So we map reads of metagenomic samples and then compare this contigs abundance before and after the infection of the bacteria. And this way we try to do various things basically. Maybe I can also present it or talk about it some other day if you point time, because it's kind of pretty big, and I've also done a little up to the moment, so maybe later I will be able to present something more on this.
Yeah.
And then I'm kind of living this cognitive science or neurobiological engagement to my master's, which I basically want to apply after my bachelor's thesis, which will be this year in the summer. So, I really applying for neurocognitive psychology master's for the fall 2020.
Yeah.
And there I kind of plan to come back more to work with the brain than with bioinformatics.
Yeah. Yeah. The next gen sequencing, it's like the whole, like there's a whole infrastructure that you need to build to like actually get the data out of the machines and then align the data and everything. And then you can do the analysis. So it's like, I think it's actually they're very powerful techniques, but they have like a lot of, like there's a lot you have to do to actually get the data processed.
Oh yes.
Which is, it's like, So it's like, usually there was, a lot of, like they say that data science is like 80% cleaning the data and like formatting it, but
and that's why it's also so cool that some public data sets exist, like GTEX. You know what I'm talking about?
Oh yeah,
GTEX consortium. Yeah, so they basically done it all for you, kind of. And of course, you don't get fresh data which you can maybe publish, because there's like tons of publications, not only of the consortium, but also some random scientists all around the world. But if you want to just have fun during some course and analyze some data and not having to clean it up yourself, then you can just take some public data sets and you'll be fine with it.
Yeah, it's a very good resource. So C. elegans, I know they have a lot of resources like for different types of data, and then of course in genomics they have all the model organisms. A lot of the model organisms they have reference maps and things like that. So those public resources I think are very useful, just tools for the general public. If you want to do an analysis, you have that all set, and that's a lot of investment that you would otherwise have to make into that infrastructure. So. That's very good. Yeah. So yeah, good job. And if you want to present something in the group here, you're welcome to do so. Just let me know, and we can do one. Set some time aside, and it would be very interesting to see what how that sort of project is going. Especially like the data science part of it, where you have like your processing data and you're actually using data to address some problem.
Yeah. Okay, that's fine. I'll inform you as soon as I have some results or something to show, because right now I just have my plan and I would be rather showing the ready product.
Yeah. Okay. Yeah. So I think that's it for today. Thanks for attending, and we'll be back next week. We'll talk more about the paper, and there'll probably be some new things to talk about. And so if anyone wants to, like I said, present or bring up some issue that they have, please let me know on Slack, and we can address it in the meeting. So have a good week. Hope everyone's semester is going to go well here. We're starting out fresh, but always new challenges. Okay. All right. Talk to you guys later.
All right. Have a nice day.
You too.